Now, number 6, we're actually going to construct a graph. Now, notice, first of all, that the exponent on the x is a 1. The exponent on the y is a 1, so this is linear. That means we're going to get a line. We will get a line, a straight line out of this. If you start putting different exponents, like 2's and 3's, you get curves. But as long as those exponents are 1's, we're going to get a straight line. Now, what we want to do is use the intercepts. Now, the intercepts, this is where a line crosses the y and x axis. So let me give a little picture here. Suppose we have a line like this. These are the intercepts. Now, this right here, that's the y-intercept. This is the x-intercept. Now, the y-intercept, this one up here, what's the x value? Well, you come down, right? We're not left or we're not right. So the x value is always going to be a 0. And for the x-intercept, down here, this is where it crosses the y-axis. So you're not up, you're not down. So in this case, the y is always a 0. All right, so to get the y-intercept, what you do is you let x equals 0. To get the x-intercept, what you do is you let y equals 0. So let's do that. So let's get the x-intercept first. So to get the x-intercept, if I let y equals 0, here's what I would get. 8x minus 3y equals negative 24. If I let y equals 0, right, I'll get 8x minus 3 times 0 is negative 24. Now that term just goes out. So you get 8x equals negative 24. Matter of fact, you don't even have to write this, right? If you're going to let something be 0, that term just goes out. And then just divide in your head. X is equal to negative 24 divided by 8 is negative 3. All right, so I get the x-intercept is at negative 3. So let's go, I'm going to plot that. So x is negative 3. So run up to the graph. Here's negative 3 on the x. So I'll put a point there. Point right here at negative 3. That's my x-intercept. Line crosses the x-axis right there. Now I'll get us some room here. So the y-intercept. Let's get the y-intercept. All right, so the y-intercept. So what I will do here is I will let x equals 0. Now, in our equation up here, I'm going to put in a 0 for x. So we'll have this. We've got 8x minus 3y is negative 24. Now, if I let x equal 0, I'll have a 0 right here, okay? So that's going to be 0. Now, 8 times 0 is 0. So this term here is going to go out, right? That's the whole point of this. This term will go out, and then I get negative 3y equals negative 24. So divide by negative 3, I'll get y equals 8. So I get y equals 8. All right, so come over to your graph. Start at the origin. X is 0, so no left or no right, but up 8. Oh, I already put the point there. All right, so x is 0, so I come up to 8, put a point there. Now I've got 2 points. That's all I need for a straight line. So now, as best you can, pass a straight line through those 2 points. Okay, now I'm going to put arrows on the ends here to indicate that those lines keep going forever in those directions. And that's our line. Now, let's be sure we understand what it means. These points, this point right here, was what? That was our first one. That was negative 3, 0. Right? So this point right here, this is negative 3 and 0. And this point up here, which is 0 and 8, now those points are on the line, and they satisfy the equation. If I put negative 3 and 0 into here, negative 3 and 0, and compute, I'll get negative 24. If I put 0 and 8 in here, if I put 0 here and 8 here and compute, I'll get negative 24. But now this is a line. Now a line is really this. If you zoom in on this, it's really infinitely many points. It's just that they all kind of blur together when we step back. But every one of these points, okay, every one of these points has an x-coordinate and a y-coordinate. And if I put that x value into here, and that y value here, into here and compute, I'm going to get negative 24. So the point is that when you draw the line, you're getting a picture of all the solutions to the equation. So where are the x and y values that make this equation true? They are right on this line. So pick any point on this line. If I pick this point right here, now I don't know exactly if my line is right, but if I take that point, say, what is it? Looks like -5, and this point here, which is -5. Okay, if I was to take that point, now this is, well, you can't even see that. Let me try again. If I try -5 and -5, if I put that into the equation, I'll get 8 times -5 minus 3 times -5. Now that gives me -40 plus 15, -40, oh, that's -25, not equal to -24. So that point is not really on the line. It's close, but it's not on the line. But here's my point. If you take any point on the line, pick its x and y value, substitute it into the equation, you're going to get a true statement. This problem 7 is very much like the last problem, except the variables are in different orders. Last time we had, what, 8x minus 3y is -24. All right, so let's do this. Let's get the x-intercept. Now, to get the x-intercept, we're going to let y equal 0. Now, let me write it. Y equals 0. So if y is 0, now, I'll write it this time, but you don't have to do this. 8 times 0 minus 3x is 24. 8 times 0 is 0 minus 3x is 24. 0 minus 3x is just -3x equals 24. So I think what you can do is, you know you're going to let y equal 0. Just put it in here, and the whole thing disappears. So you can go right from here down to here. Now, that means that x is equal to -8. There's our x-intercept. So let's plot that. So over on the graph, there's our origin. Come over to -8 on the x-axis. It is right here, and I will put a point. Now let's get our y-intercept. So to get the y-intercept, right, we want the y-intercept. So we will let x equal 0. Now, put that 0, take that 0, put it right here for x, right? Put the 0 for x. 3 times 0 is 0, so that term is gone. So that's what's nice about this method. That disappears. So now you're left with 8y is 24. And you can solve that, just divide by the 8. So y is equal to 3. There's our y-intercept. Now, let's find it on the graph. Let's plot it. So start over here at the origin. Y is 3. X is 0, right? So no left or right, but y is 3. So up 3, there we are right there. So I'm going to plot that point. Now I've got 2 points. As best you can, pass a line through those 2 points. So let's see if I get my straight edge on here. That looks pretty good. So I'll put my arrows on. And there's our line. And now just keep in mind what it means. It means if I pick any point on this line, now any point on that line has, like, okay, I'll pick this point right here. Pick that point right here. There's an ordered pair. There's an x value, and there's a y value. And what it means, of course, is that if I take that x value, substitute it in here, and take that y value and substitute it in here, I'll get 24. Now, that's true for every point on that line. But if I pick a point off the line and compute, I'm not going to get 24. I'm going to graph this equation using the slope-intercept form. Use the slope-intercept form. Now, here's what I know. If you have an equation, y equals mx plus b, that multiplier of the x, that's the slope. And that number out there by itself, that constant, that is the y, intercept. So just looking at this one, I can tell that number out there by itself, that's 7. That's where the line crosses the y-axis. So I come over here to y equals 7, and I can put a point. So I'll do that right away. Goes through here. Now, this number here, that multiplier of the x, that's a 2, that's the slope. All right, so in our case, the slope, that's the slant of the line, that's m, that's what we call it, and this is equal to 2 in our case. Now, write it as a fraction, 2 over 1. Now, the bottom number tells you the horizontal change, and the top number tells you the vertical change. So start at a point on the graph that you know. Now we know this point right here, 7. All right, so I'm going to start at 7. So come over to the graph, start at 7. Now make these changes. This says if I start at this point, now come down here, if I make a horizontal change of 1 unit, now it's positive, so I'm going to go 1 to the right, and then a vertical change of 2 units, so 2 up, I'll be back on the graph. So come up to your 7. Now I'm going to go right 1, up 2. That puts me right here. So put a point right there. Over 1, up 2. Now that's pretty tight, but do the best you can to draw a line through. But you could also do this. If it's pretty tight like that, what you could do is this. Notice that m is equal to 2, which you could actually write as -2 over -1. It just goes in the opposite direction. So what I would do now, I would start at my point 7, right? I'm up here on the graph, start to 7, go now, what movements do you make? Bottom number is the horizontal, so go to the left 1, top number is the vertical, down 2. So starting at my 7, I'm going to go to the left 1, down 2, put a point right there. Looks like those 3 are on the picture. I could do it again. Go to the left 1, down 2, right there. To the left 1, down 2, right there. Okay, now I've got a bunch of points. Maybe I can get a reasonable line through them. All right, and there's my graph of that equation. Now I'm going to graph this equation using the intercept method. So here's the x-intercept. The x-intercept, I'm going to let y equal 0. And if you let y equal 0 up here, what do you get? If y is 0, then y is 0, so that's gone. You get x is 4. All right, so I'll get x equals 4. There's my x-intercept. So let's plot it. Come over to the graph, start the origin, and x is 4. So I'm going to go over to 4, and y is 0, so I'm not up or down. I'm just right here at 4. Now, get the y-intercept. So to get the y-intercept, I'm going to let x equal 0. And if you let x equal 0 up here, put 0 in for x, what you get is, I'll write this one, it's negative y equals 4. So I'll multiply by -1. You get y equals -4. All right, so let's plot that point. So come over to the graph, start at the origin. Now x is 0, so no left or right, but down 4. Down 4. There is a point on the graph. Now pass a line through those 2 points as best you can. Get a picture of where all the solutions are. And there's our graph. And remember what it means. Pick any point on the line. Pick any point on the line like that one. Get that x-coordinate and that y-coordinate. Put that x and y here, and compute. You'll get 4. I'm going to graph this equation using the slope-intercept form because here's the form I have. I have y equals mx plus b. Now b, that's that number right there. That's where it crosses the y-axis. We know that one. That's 3. Let's just go over to 3 and put a point right away. All right, so here's my origin. Here's 3 right here, so I'm going to put a point. That is the y-intercept. Now I need another point. I'm going to get the other point using the slope. And the slope, that's this number right here. Right? So we're saying that the slope is equal to negative, book's writing it like this, -3 over 2. Right? The multiplier of the x, m times x, the multiplier of the x, that's the slope. Ours is -3 over 2. I'm going to write it like this. I'm going to put the negative sign on the top, -3 over 2. Now the bottom number is the horizontal change. So you start at any point on the graph, you make a horizontal change of 2. You go 2 units to the right because it's positive. So you go 2 units to the right, then you go down 3. The top number is the vertical change. All right, so here's what I'm going to do. I'm going to go over to this point on the graph. So I'm over here on the graph. Start at some point on the graph. I know that one. Now, make these changes. I am going to go to the right 2, right because it's positive, and then down 3. Bottom number is the horizontal change, top number is the vertical change. So back here, not at the origin, you want to point on the graph. I'm going to go to the right 2, 1, 2, and down 3. 1, 2, 3. Looks like it's right there. So I'll put that point right there. Over 2, down 3. I think I've got it. And pass a line through those 2 points. There we go. I've got that graph.